What happens when a cell runs out of tryptophan? It dreams about synthesizing. First it needs a plan. Just look at the genes inside it, coded in its DNA. All it needs are 5 quick enzymes. Now Operon come in play. Inside the cell.
Inside the cell.
Inside the cell.
Inside the cell.
5 structural genes code for 5 proteins to make tryptophan. But it has a repressible gene regulated by attenuating. Trp Operon only works when there's no tryptophan. Repressor for the operon comes from the gene Trp. Repressor is always made, not always DNA secured. When there is tryptophan, the repressor makes a move. Co-repressor leads to shape change. Operator is its goal. Inside the cell.
Inside the cell.
Inside the cell.
Inside the cell.
5 structural genes, Trp A, B, C, D, and don't forget E. When a repressor binds to DNA, transcription has been blocked away. Trp Operon only works when there's no tryptophan. When tryptophan is low, free repressor cannot bind. RNA polymerase can ultimately promote or find. Structural genes can be made, but watch for attenuation. There's still some more regulation before we make tryptophan. Inside the cell.
Inside the cell.
Inside the cell.
Inside the cell.
5 structural genes code for 5 proteins to make tryptophan. But it has a repressible gene regulated by attenuating. Trp Operon only works when there's no tryptophan. The Trp leader gene consists of 4 regions. Sequence 1, 2, 3, and 4. Some pairs can form hairpin loops, like region 2 can with 3. So can region 3 and 4, which do the attenuating. Come on, let's explain some more. Inside the cell. Inside the cell. The Trp Operon is regulated by attenuation. It works after transcription starts, but before transcription is done. Trp Operon only works when there's no tryptophan. Attenuation is all about the leader sequence. It contains 2 trip codons, which is not too common. If there is a lot of trip, it goes on the growing peptide. If the cell doesn't have any trip, then there's nothing to add. Inside the cell.
Inside the cell.
Inside the cell.
Inside the cell.
When trip is high, there is no pause. In region 1, loop forms between 3 and 4, prevents transcription of operon. Only works when there's no tryptophan. Inside the cell.
Inside the cell.
Inside the cell.
Inside the cell.
Region 4 and 3 form a hairpin loop full of G's and C's. The structure will make transcription cease. No translation mRNA is complete. Trp Operon only works when there's no tryptophan. Now in attenuation, and when tryptophan is low, the ribosome pauses in region 1. A loop forms between 2 and 3, but it's not a termination site. Transcription of structural genes, continued tryptophan is made. Inside the cell.
Inside the cell.
Inside the cell.
Inside the cell.
To make tryptophan, 2 things must happen simultaneously. Repressor can't bind to DNA. Region 3 and 4 can form a loop. This only works when there's no tryptophan inside the cell.
Inside the cell.
Inside the cell.
Inside the cell.
The Trp Operon makes tryptophan so easily. As long as concentration is low, regulation lets transcription go. 5 structural enzymes make tryptophan inside the cell.
Inside the cell.